In this video, we shall discuss about the application of different equation. So it's gonna be like in the future value, in the loan payment or something. So it's gonna be like you're gonna create the different equation and you're gonna solve for the formula that you may already know about this one. So the future value, we like to find the future value of the following sequence of deposit. We assume that the deposits are made at the end of compounding period. Okay, so we have $400 a year at 5% annual interest, and you like to deposit this guy for X year. So the amount of money at the first month, so it's going to be a zero at the initial period. Okay, so I'm not gonna care about the principal, so it's gonna be, I'm gonna call the principal P. Okay, so the money that you deposit for each month. Okay, so it's gonna be the thing that you deposit, and you're gonna have 500, and you're gonna have the annual interest. So it's gonna means that you're gonna have 500%, not 500, 5% per year. So it's gonna be 5/100. So this one will be your R that is gonna be compound yearly. Okay, so you're gonna have R equal to 5/100. So you have your P, your R. So you have your A0 equal to, so you let AX be the amount of money at the end of X year. Okay, so we let AX to be the amount of money at the end of X year. So you would get A0 equal to P, your principal. Okay, and for the second year, so it's going to be, for the second year, you're going to have A1 minus A0, A1 minus A0, which is the difference between your money. So what happened at the end of the first year? At the end of the first year, you're going to have your interest, which is A0 multiplied with R. Okay, so it's going to be A0 multiplied with R, and you're going to add new money. Okay, so this guy will be the new deposit. Okay, so for this one, it's going to be you have your new deposit. Okay, and for this one, you're gonna see that this will be A1 equal to, so you're gonna get this amount of money, so you would get A1 equal to A0 times 1 plus R plus the money that you knew that you deposit for the end of the first month. Okay, the second month turned out to be the same, so the difference between the second month and the first month turned out to be A1 times R plus P. So in this case, it's gonna be, you're gonna have A2 equal to A1 times R plus 1 plus R plus P. Okay, so this one will be your A2. So you do this guy, so you get AX plus 1 minus AX. So AX plus 1 minus AX will be just AX, which is the amount of the money previously. So multiply with R. Okay, so multiply with R plus P. Okay, so you're gonna get a different equation. So you get ax plus 1 equal to ax. So it's going to be ax times 1 plus r plus p. Okay. And you have a0 equal to p in this case. Okay, so you have a0 equal to p in this case. So you would solve for this guy. So you're gonna put in the form that we already know. So we need to solve this different equation. So this one turned out to be non-homogeneous. So you get ax plus 1 minus 1 plus r ax equal to constant p. Okay, so this guy is turned out to be constant. Okay, so you know that you're gonna have two steps. Step 1 is gonna be the homogeneous. So the homogeneous, you're gonna get that x equal to 1 plus r to the n times constant c. Okay, so it's going to be 1 plus r to the n times constant c. And you have step 2. Okay, so you have step 2 is turned out to be you have what is called, you have the constant part for this one. So you gonna let ax tutor to be it's going to be ax tutor to be constant k. Okay, so it's going to have to be the same degree as your principal p that you know, and you're gonna have ax plus 1 tutor turn out to be, okay, so you have ax plus 1 tutor to be k as well. Okay, and you would put into the different equation. So you're gonna put into the yellow guy and you be able to solve for k. So you would have k plus 1, okay, put into 1. So you would be able to put to solve for k, so it's going to be k minus 1 plus r times k equal to p, and you're gonna have k equal to, so this one will be r, so it's going to be p over r. Okay, so you have k equal to p over r, which already know, and you're gonna have the solution. So you get ax equal to zx plus a tilde x. Okay, so it's going to be zx plus a tilde x that I used to highlight the pink guy. Okay, so I used to highlight the pink guy, which is a tilde x. Okay, and you have your zx is the gray one. Okay, so you have zx plus a tilde x. So you're gonna just answer 1 plus r to the n. Okay, so it's gonna be 1 plus r to the n times constant c, and you're gonna plus p over r. Okay, so this one will be your ax. And so you're gonna have a 0 sin a0 equal to p. Okay, so you have a0 equal to p. So we have a0, so it's going to be p equal to, okay, so we have p equal to c plus p over r. So you would get C equal to the principal minus, so it's going to be P 1 minus 1 over R. Okay, so that will be your C. Okay, so it's going to be P minus P over R, kind of. Okay, so the formula that you will have turn out to be AX equal to, let we put them together. So it's going to be 1 plus R to the N times C, which is your principal, 1 minus 1 over R plus P over R. Okay, so this one will be the amount of money that you have. Okay, so it's going to be to the X, right? Not to the N, to the X. Okay. Okay, so this one will be just, you know, P, you know, R. Okay, so this one will be the formula for the compound interest when you know the rate that is going to be compound yearly, compound monthly. So you're going to have R differently, and you have your P is your principal that you put into the bank at each month. Okay, so for this one, it's going to be this one. You may put into the formula that you know, but I don't quite care about this one. So I'm going to just make it like this. And you're going to see that for question A, right? It's going to be A, right? So for question A, you have P equal to 400 and you have R equal to 0.05. Okay, so you would get AX equal to 1 plus 0.5 to the X times 400, and you have 1 minus 1 over R. So 1 over R will be 20. So it's going to be, so 1 minus R is going to be, so you get P equal to 400. Okay, so 1 minus 1 over R. Okay, so 1 minus 1 over R. Yeah, it should be okay, right? So this one is gonna be 400 and you have 1 minus 1 over R. So this one is gonna be 1 minus 1 over R. And it's gonna turn out to be plus what is called 400 over R. Okay, so this guy will be the thing that we have, and R in this case is 0.05. Okay, so it's going to be R equal to 1 over 0.05. Okay, so this one, let me check the size a little bit. Did I make mistake or something? So you have K. I make mistake. I miss one side. That's why it's so strange. So I have minus here. Okay. So you get K equal to minus side here. So that's why my side is very strange. So you get this one and it's going to be plus. Okay. So sorry about that. Okay. So it's going to be plus here. And it's turned out to be minus side. Okay, so that is correct right now. Okay, so basically this one will be just what is gonna be. So it's gonna be 21. So for this one, it's gonna be 1.05 to the X, 4 times 21. So this guy is equal to 20, right? So this guy equal to 20. So for this one, it's gonna be 400 times 21, which is 8,400 minus 8,000. Okay, so this one will be the amount of the money that you have in the bank. Okay, so you have x greater than or equal to 0. The second one, you have A, so you have B. So for B, you have the principal equal to 500, okay? And you have R that 6%, okay? However, it's not compound annually, so it's gonna be 6% that you divide into 12 months because you compound monthly. Okay, so this one is monthly. Okay, so you compound this guy monthly. So for your AX in the second case, it's gonna be you plug into the formula. Okay, so I have negative sign here. So you plug into the formula, so it would give you 1 plus 0.06 over 12 to the x, okay? And you gonna have p, which is your 150, and you have 1 plus 1 over r, 1 plus 1 over r, okay? So it's gonna be 1 plus 1 over it's gonna not be nice number, so it's gonna be 1 plus 1 over 0.06 over 12, okay? And you have minus p over r. Okay, so it's minus 150 over 0.06 over 12. Okay, so that will be your R. Okay, so that will be your R, and this one will give you the like a compound interest formula for AX and X positive of 0. Okay, so this one you may use this one, or you may simplify this one a little bit. Okay, so that would be fine. So basically this one will be what? So if you like to memorize AX, so you may memorize this AX in this way, or you may have a better way to memorize this guy, like, okay, so you see that you're gonna have AX equal to, okay, so it's gonna be P over R. Okay, so it's gonna be P over R, and you gonna get 1 plus R to the X plus 1, okay, minus 1. Okay, so that will be just simplification for that long formula, right? So it is 1 plus R to the x plus 1. Okay, so when you have x equal to 0, when you have x equal to 0, you would get p. Okay, it's also correct. Okay, so this one will be another formula for the compound interest. Okay, I hope that is not too dark. Okay, so the next one, we like to find a monthly payment. Okay, so a monthly payment must take to pay off a $5,000 debt with interest 4.2% compound monthly in 3 years. Okay, so it's going to be compound monthly. So when you see something like this, you're gonna have the rate. So in 3 years, so you have 36 months. Okay, so you translate the question a little bit. So you have 36 months to pay off this debt, and 4.2% compound monthly is gonna be R equal to 0.042 over compound monthly, so it's going to be over 12. Okay, so that will be your R that you have the rate of interest, and you have your debt equal to 5,000. Okay, so you have your debt equal to 5,000. So for this one, I would gonna let AX. Okay, so to be the amount of debt after X month. Okay, so I would let AX to be the amount of debt after X month. So this one will be debt. So for this one, and you're gonna let your R to be the monthly payment. Okay, so we're gonna let R to be the monthly payment. So you would have A0, which is the amount of money that you have, not amount of money, amount of debt that you have first. So it's going to be 5,000. Okay, so you not pay anything back like right at that first month, at that initial month. Okay, and what will happen after the end of the month? So you see that the debt turned out to be smaller. So you have A1 minus A0. Okay, so the difference between A1 and A0 turned out to be the interest that you have. So it's going to be 5,000. Okay, so it's going to be 5,000, and it's going to be multiplied with the interest that you have. So it's going to be 0.042 over 12. Okay, so that will be the amount of money that you have. And then you also have the difference with your monthly payment. So it's going to be minus R. Okay, so your monthly payment. Okay, so the debt will be reduced. Okay, so the debt will be reduced. So it's going to be 5,000 times 0.02, 0.042 over 12. So you see that we may do this one in the general way. So you have A0 equal to the debt that you have. Okay, so the debt that you have, let's say this guy equal to your P. So it's going to be your P. Let's use A0 is the amount of money that you have your principal debt. So it's going to be P equal to 5,000. Okay, and you have your A1 minus A0, which is P times R. Okay, so you have P times R, and you gonna have minus the monthly payment that you have. Okay, so that will be the change in your debt. So your debt will become smaller, and you gonna get, okay, so for this one you still have A2. Okay, so A2 minus A1 turn out to be the money that you have for A1. Okay, so it's going to be A1, and you're going to multiply with R, and you have your monthly payment. So for not confusing you here, I'm gonna just say A0, right? So this one is A0. So it's gonna be counting the interest only for the periods that you have your money A0, okay? And this one is gonna be, you compute the interest only on the amount of money that you owe. So it's gonna be A1R minus R. And you continue this process, you see that the pattern turned out to be kind of the same. So you see that you have AX plus 1 minus ax equal to ax times r minus r. Okay, so you see this pattern and it's gonna turn out to be the same, but the difference turn out to be p. Okay, so it's gonna be the one that you have. So you have ax plus 1 equal to 1 plus r ax minus r. Okay, so you see that this different equation turned out to be exactly kind of the same as the previous one that we have for first equation. Okay, so this one will be the green one as you have seen before. Okay, so this is the green one that you have seen before, and you gonna, okay, so you gonna be able to solve for ax. Okay, so it's gonna be two steps, step 1, step 2 as before. So let's solve. I don't want to confuse you. So here you have a1, so you have ax. Okay, so not a1, step 1. So for this one, it's going to be 2 steps. Step 1 is going to be the homogeneous part. So for homogeneous part, you have set x equal to 1 plus r constant. Okay, 1 plus r to the x times constant. Okay, and you have your step 2. Okay, step 2. So you're gonna let a to the x to be what? A to the x to be constant k. Okay, and you see that you have your constant k. So you're gonna have a to the x plus 1 will be k. Okay, so you get r equal to kr. Okay, so you have to put them here. So it's going to be, let me put them here. So it's going to be k equal to 1 plus r, k equal to, not equal to, minus r. So you would get what? You would get k, okay, equal to r over r. Okay, so here is going to be positive. Okay, so it's going to be positive side. So that will be your k. Okay, so that will be your k. And you're gonna have, okay, so you have your k, and you're gonna have your general solution. So you have ax turn out to be the homogeneous part. So you get the homogeneous part is 1 plus r to the x times c plus by the ax tilde, which is k. So it's going to be r over r. Okay, so it's going to be r over r. Okay, so it's going to be a little bit different than the previous one. Okay, however, kind of the same thing. So you have this one and you have a0 equal to the debt that you have, which is your principal P. You have your principal P for your debt. So for this guy, okay, my variable not quite good. It should be B, right? So for this one, you get A0, so you get C. So you have P equal to A0 equal to C plus your R over R. Okay, so you would solve for C. C will be P minus R over R. Okay, so that will be the thing that we have Okay, so that will be you solve for C in the previous case. Okay, so it's going to be P. It's going to be, let me have A0 equal to P, and you have this one. Okay, so you have C equal to 1 minus R. So for this one, you're gonna get AX equal to 1 plus R to the X, and C is P minus R over R, and you're gonna add by R over R. Okay. So this one will be the amount of money that you want to pay, okay, in X month. Oh, sorry. This is the amount of debt that you have in X month. Okay. So since 36 equal to 0, okay, so you like to pay off this debt in 36 months. Okay, so we would get, okay, so we would get 0 equal to 1 plus R to the 36, and you have P, which is P minus R over R, okay, plus R over R, okay, and you would want to solve for the capital R, okay, so you want to solve for the capital R, okay, so we know P, which is 5,000, okay, so it's gonna be 0, okay, so it's gonna be here 0 plus I'm not gonna put R because my R is kind of not nice. Okay, so 36. Okay, and your principal is 5,000. Principal is 5,000. Okay, so basically we can just, so in terms of P and R, so you get the formula. It should be better, right? So for this one, you see that we allow to write this one. So it's gonna be, where should I put this one? Let me see a little bit whether I should have the formula in what form. So I should have, okay. So I should keep my R, okay, so I should keep my formula in this way. So it's gonna be, does it matter? No, it's not matter. I'm gonna move everything to the other side. So it's gonna be 1 plus R to the 36, okay, minus 1, and everything is going to be R over R equal to 1 plus R to the 36 times P on the other side. Okay, so this one will be just like that, okay? And then you're gonna have your R times 1 plus R to the 36 times P. Okay, so we would want to solve for the capital R over, okay, so over 1 plus R to the 36 minus 1, okay. However, you see that this one is a little bit messy, so we're gonna multiply 1 plus R to the negative 36 on top, and you have 1 plus R to the negative 36 on the bottom. And you see that this will give you your R, which is your monthly payment in the form of, okay, so it's going to be the monthly payment in the form of R times P over, and you multiply this one, it's going to be 1 minus 1 plus R to 36, Okay, so it's gonna be the number of the period here. So for this one, it's gonna be the number of the period. Okay, so this guy is the number of the period. Okay, so it's going to be the number of the period, which is 36. Okay, so this one is the formula for the monthly payment that you have. Okay, so this one, if you like to plug everything in, you'll be able to just plug in R. Okay, so you have R equal to 0.042 over 12 because this guy is monthly. And you have your principal P equal to, okay, so you have your principal P equal to 5,000. Okay, so that will be R that you can evaluate for value using the calculator. I think I made mistake. It's going to be negative 36. Okay, so I forgot the negative side, the important one, kind of. The next example will be you like to buy a car, so receive 125. Okay, so it's going to be 1250 credit back. Okay, and it's going to be you like to buy a new car costing 3,750. Okay, so when cash down payment will be necessary. Okay, so I think I'm not gonna be when, what? Okay, so it's gonna be what? Okay, so it's gonna be what cash down payment will be necessary so that the balance can be liquidated by the payment at 125 at the end of each month for 18 months. Okay, so we like to know the loan that you have. So you need, okay, so from R equal to, okay, so you have R equal to R, okay, and in this case, it's going to be 6% compound monthly. Okay, so it's going to be, you have your R equal to 0.06 over 12. Okay, so you have 0.06 equal to 12. You have X equal to, so it's going to be 18 months. Okay, so this one will be another information. So you have 18 months. So you need to solve for P. Okay, so for monthly payment, it's going to be, so let me write down the formula first. So it's going to be P over 1 minus 1 plus R to the negative X. Okay, so this one. So you have X equal to 18 that you analyze. Okay, so you have X equal to 18. You have R, which is 125. Okay, so you'd like to know the amount of your loan. Okay, so in this case, you're gonna know P. So this one will give you the amount of the loan. Okay, so you have the amount of the loan. Okay, so it's gonna be 0.06 over 12. So this one, you have your R equal to 0.005, right? So it's gonna be 3-digit decimal in that way. And you're gonna have, so you're gonna just plug in 0.005. Okay, so that will be your R, and your P is your amount of your loan over 1 plus, not 1 minus, 1 minus, so it's going to be 1.005 to the negative 18. Okay, so this one will be your formula, and you would solve for P. Okay, so you have your P, which is the amount of your loan, turn out to be 125 times 1 minus 1.005 to the negative 18. Okay, and it's gonna be over 0.005. Okay, so this will be the number of P that you need to loan. Okay, so it's gonna be the amount of the money that you have. So you like to know what it's gonna be. Okay, so what is the down payment? So what is the down payment? It's gonna turn out to be 30, what do you call 30,150. Okay, 3,750. And it's gonna be come from 1 to 50, which is the cashback. Okay, so it's gonna be the credit that you sell your old car, and it's gonna be the amount of loan plus down payment. Okay, so you know P already. Okay, so the down payment would be 3750 and minus 1250. Okay, and minus the P here. Okay, so here you can use your calculator to give me that number, and you see that you have your down payment. Okay, so for this one, it's going to be just applying the formula in the previous example. Okay, so for this one, if the question does not ask you to solve or set up the different equation, you may not have to, but the question may ask you to set up and find the solution of the different equation that show here. So it's going to be, you have to work on something like this that we have done in this video. Okay. Okay, so that's it for this course. Next week, I'm gonna give you the review for everything, and you're gonna have the homework in order to review everything as well. Okay, so see you again next week.